When we consider the trends in the properties of group 2 metals and their compounds, we invariably leave beryllium out because the element shows some very strange properties. Beryllium has a number of isotopes, but the most stable has 4 protons in the nucleus and 5 neutrons, and it has the electron configuration 1s2, 2s2. So we've got 2 electrons in the 1s orbital and 2 electrons in the 2s orbital. Unlike other group 2 elements, it can lose its 2s valence electrons to form a beryllium ion with a 2+ charge. This ion has an exceptionally high charge density, a double positive charge and only a very small ionic radius, which means it's exceedingly attractive to everybody else's electrons. Let's take beryllium carbonate as an example. When the carbonate ion is in close proximity to the beryllium ion, as it will be when it's in the beryllium carbonate lattice, the electron density of the anion is highly polarized. The carbonate ion becomes distorted and the beryllium carbonate bond takes on a distinctly covalent character. In fact, beryllium carbonate is innately unstable and decomposes to form beryllium oxide and carbon dioxide if not stored under a CO2 atmosphere. In beryllium chloride, we don't just have ionic bonds with a covalent character, we actually have covalent bonds. Clearly, this is not usual for a metal chloride. We can see this more clearly on the structure. We've got our beryllium atoms and our chlorine atoms. Each beryllium is making a single covalent bond to 2 different chlorine atoms, and then 2 more chlorine atoms are making dative covalent bonds to the beryllium. And in a dative covalent bond, both the electrons are coming from the chlorine atom. Now, beryllium does react readily with acids just like all group 2 metals. So, for example, we can have beryllium reacting with sulfuric acid to give us the metal salt, beryllium sulfate, and hydrogen. And we see this with the rest of group 2. What's unusual, though, is that beryllium will also dissolve in an alkali to form a beryllium hydroxide complex. So our beryllium dissolving in our alkali, hence the hydroxide ions, and this complex, H4, has the name tetrahydroxoberylliate ion, obviously. And we can see here in the image that in this complex ion we've got covalent bonds between the beryllium and the hydroxide ions, and this complex has a 2- charge overall. You can find out more about the properties and reactions of group 2 metals on the Crunch Chemistry website. There's a link in the blurb below. And if this has been useful, then please like, share, subscribe. It makes a huge difference to a small channel like us. I look forward to seeing you next time.